Hello and welcome. Today we're diving deep into a topic crucial for any high-scale system, designing truly scalable log ingestion. We'll explore how to move beyond the traditional approaches and build systems that can handle hundreds of thousands, even millions of events per second without breaking a sweat. By the end of this lesson, you'll have a clear understanding of when and how to leverage User Datagram Protocol, or UDP, for your high-throughput data needs. You'll gain practical insights into architecting reliability at the application layer, a skill often overlooked but essential for robust distributed systems. We'll also cover advanced strategies like adaptive protocol switching and smart load shedding, which are key to maintaining performance under dynamic network conditions. Finally, we'll equip you with the knowledge to identify and monitor the critical metrics that indicate the health and efficiency of your UDP-based log ingestion systems in real-world production environments. Get ready to unlock new levels of performance for your data pipelines. Let's kick things off by understanding the TCP tax. While Transmission Control Protocol, or TCP, is the workhorse of the internet, its built-in reliability comes with significant overhead, especially at scale. For applications like a large social network processing millions of playback events, or a major ride-sharing service handling countless location updates, TCP's three-way handshake, congestion control, and guaranteed delivery mechanisms can add 40 to 100 milliseconds of latency per connection. This tax consumes substantial server resources just managing connection states, becoming a performance bottleneck. This is where UDP shines. By eliminating these overheads, UDP offers 3 to 5 times higher throughput for workloads where occasional packet loss is acceptable. Think of it for metrics, traces, or logs, where losing a tiny fraction of data doesn't compromise overall system understanding. The critical trade-off, however, is that you inherit the responsibility for handling packet loss, ordering, and flow control at the application layer. It's a powerful tool, but it demands a different mindset. When you choose UDP, you're taking on the challenge of reliability, but fear not, there are established patterns to guide you. First, a sound protocol selection strategy is paramount. The industry standard is to use UDP for high-volume telemetry, like logs, metrics, or traces, where individual message loss can be tolerated. Conversely, critical transactional data, like financial transactions, absolutely requires TCP's guaranteed delivery. Next, since UDP doesn't guarantee ordering, you'll need application-level sequencing. This involves adding a monotonic, wrap-safe 64-bit sequence number to each message. This enables your receiver to detect lost packets, reorder out-of-sequence messages, and identify duplicates. A famous production incident at a large social media company highlighted the danger of using 32-bit sequence numbers, which wrapped too quickly, causing chaos. Finally, adaptive protocol switching is key. Network conditions are rarely static. Your system should dynamically switch to TCP if packet loss exceeds a threshold, say 5% over a 60-second window, and then intelligently attempt to switch back to UDP when conditions improve, using an exponential backoff to prevent rapid, destabilizing oscillations. This prevents alerting fatigue and maintains throughput. To truly maximize UDP's potential, we need to talk about efficiency and resilience. First, batching and framing are essential. UDP's maximum transmission unit, or MTU, is typically around 1,500 bytes. By packaging multiple log events into a single UDP packet, you amortize the per-packet overhead, significantly improving network efficiency. Your framing strategy should include a batch size and sequence number, followed by individual message lengths and data. The trade-off is that larger batches increase the blast radius of packet loss. Losing one large packet means losing many events. Benchmarking often shows 10 to 15 messages per packet as optimal for typical log sizes. Second, server-side load shedding is critical. High-throughput UDP servers can overwhelm the kernel's receive buffer, silently dropping packets before your application even sees them. You must proactively tune your operating system's UDP receive buffer size, for example, increasing net.core.rem max on Linux. Beyond kernel tuning, implement application-level load shedding. Track your processing queue depth, and if it exceeds a threshold, send a negative acknowledgement, or NAC, back to the client, signaling them to slow down or switch protocols. This is how major cloud providers handle massive ingestion spikes without over-provisioning. Bringing it all together, let's look at what truly matters in production. In high-throughput scenarios, UDP consistently outperforms TCP by 400 to 500%. However, this performance degrades non-linearly if your kernel buffers overflow, so continuous monitoring of REM max utilization is essential. For monitoring, focus on key metrics: your packet loss rate, aiming for less than 0.5%, your messages per second throughput, and the UDP versus TCP protocol distribution to understand your system's adaptability. Also, track kernel buffer overflow counts using tools like netstat.su. Be prepared for common failure scenarios. Kernel buffer overflows require pre-allocated buffers and load shedding. Network infrastructure blocking UDP necessitates your TCP fallback with a robust circuit breaker. And resource exhaustion can be mitigated by capping in-flight messages per client. Companies like a prominent monitoring service use UDP for metrics, handling 500K metrics per second per host. A major ride-sharing company processes millions of location updates via UDP, accepting a small loss rate because updates are frequent. The foundation we've built today is critical. As a self-assessment, consider this. When would you recommend UDP over TCP for a new data ingestion system, and what specific application-level reliability mechanisms would you implement?